Namaskar everyone. Indian Master Ji welcomes you to this YouTube channel. Let's begin with this video. In this video, we are going to understand the concept of expectation and variance for a random variable x. Suppose I have got a fair die and I throw it once. Okay, and I try to find out the score which I get on the upper face. Score on the upper face of the die. So the score on the upper face, I can represent it by a random variable. Suppose x is a random variable which represents score on the upper face of the die. Representing score on the upper face. On upper face of the die. Okay. So what all score I can get? X can take a value 1, 2, 3, 4, 5, 6. Correct? So I'll write down the score by a small variable x. Okay. Now suppose if I perform this particular experiment, that is throwing of a die 180 times, then each time I will get one of these 6 values. Suppose I count each time what values I get. So that will represent the frequency of each score, correct? So suppose if I write frequency by the small letter f and I try to write down the frequency. Suppose I say that 1 I get 27 times out of 180 times. 2 I get 33 times. 4 I get 34 times. Sorry, 3 I get 34 times. 4 I get 25 times. 5 I get 35 times. Okay, and 6 I get 26 times out of 180 times. Okay, so here n, which is nothing but summation of all these particular frequencies, is equal to 180. Correct? If I have to find out the mean score when I have thrown the die 180 times, how will I find out the mean score? The mean score will be equal to summation of xi into fi divided by summation of f, where I is taking values here in this particular experiment 1, 2, 3, 4, 5, 6. There are 6 values. Okay, so x1 here, when I is equal to 1, x1 is 1 here, and its frequency f1 is 27. Similarly, x4 is, that is the fourth x value is here 4, and its frequency is how much? f4, that frequency is 25. Correct? So if I have to find out the mean score, I will have to do this particular summation and divide by 180. Let's try to do this. So in the numerator, I'll get 1 into 27 plus 2 into 33 plus 3 into 34 plus 4 into 25 plus 5 into 35 plus 6 into 26. Correct? Let me take this little bit up. Okay, here. Divide by 180. So here what will be x bar now? That the mean score will be equal to 626 divided by 180. And this value on calculation, we will get it as 3.4777 something something. So in terms of 3 significant figures, I'll get it as 3.48. Okay. So now I ask you the question, what is the expected value? What is the theoretical value of this particular mean score? Let's try to find out the theoretical value of this particular mean. So again, I'll take the scores. So scores will be what? 1, 2, 3, 4, 5, 6. And probability of x, that the score taking the value x, that is capital X taking the value small x, will be equal to what? If it is a fair die, then x taking a value 1 will be 1 by 6. Similarly, 2 will be 1 by 6. For 3, 1 by 6, 4, 1 by 6, 5, 1 by 6, and 6, 1 by 6. This is what? This is the probability distribution for the random variable x. Correct? Here we see that summation of all the probabilities for all values of x, this is equal to what? 1. Correct? Let's try to find out the expected value of the mean. So what is the expected value here? Mu will be equal to, we write it as mu or E of x. Okay, this will be equal to summation of x into probability of the random variable x, capital X taking this small value x. Okay, so I will have to find out summation of all this particular product. So what I'll get? I'll get this as 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. So this mu, if I try to find out by calculating these values, what I'll get? I'll get this as 3.5. So that means if a die is thrown, fair die is thrown, then the mean expected is 3.5. So if I keep on increasing the n value, if I increase n, instead of n equal to 180, if I make it 200, if I make it 2000, if I make it 20,000, then this x bar, which is here 3.48, should tend to this value, that is 3.5. This 3.5 is nothing but the expected value when we are increasing the n. Okay, as n increases, x bar tends to mu or E of x. Okay. So for a discrete random variable, the mu or expected value of x, expected value of x, this is also called as expected mean, or this is also called as expectation of x. Okay, or simply it is called as mean also many a times. So this mu is equal to summation of x into probability of the random variable x taking this small value x. Okay, so for all values of I can be what? 1, 2, 3. Here I will put I varying from 1 to n, and this is xi here. Okay, and probability of xi, where I is varying all the values it is taking, 1, 2, 3, 4, 5, and so on up till n. So these are what? These are discrete values it is taking here. If you see, these values 1, 2, 3, 4, 5, 6 are what? Discrete values it is taking. So that's the reason here x is a discrete random variable. Now for the same discrete random variable, let's try to find out variance. Okay. So variance of x, if I have to find out, it is nothing but it is a measure of spread. Measure of spread of x. Spread of x about what? about the expected mean, about the expected mean E of x. Okay, E of x or mu. How do we represent it? We represent it by variance of x like this, var x or sigma square. Okay. So for a discrete random variable x, the variance of x is given as variance of x or sigma square. This is given as summation of xi square into probability of x taking the value xi. Okay, this summation minus E of x square. Okay, so this in turn, this is what? This is something like mean of x square. Correct? Can I say this is mean of x square minus, here inside the bracket it is mean of x. So variance of x is mean of x square, okay, minus square of mean. Let me write this properly. Okay, mean of x square minus square of mean. Many a times we write it like this: mean of square minus square of mean. Okay, sometimes we write it like this also: summation of x square into p minus of mu square, where the random variable x is taking values small x, okay, and each small x will have its own probability small p. So x square into p ka summation will do, we do, and from that particular summation we subtract mu square. Okay, this is how we find out the variance of a discrete random variable. Can we extend the same concept, okay, to a continuous random variable x? Yes, we can do this, but there is one problem. For a continuous random variable x, okay, suppose if we try to draw the probability density function f of x, suppose this is the probability density function f of x for the continuous random variable x, okay, we know that probability of x taking a value equal to x for a continuous random variable x is equal to 0. Okay, this probability is equal to 0. So I can't directly use this particular formula. So that means p is equal to 0, correct, for x taking a value equal to x. So I can't directly use this particular formula. So but what I know is this random variable x can take a particular value, can take a value in a given interval. Suppose this is the interval I talk about. Can x take a value in this particular interval? Yes, it can take a value in this particular interval. And what is the probability of x taking a value in this particular interval? That probability is given by the area under this probability density function curve. Correct? So if I try to find out the addition of all the areas, if I try to find out the addition of all the areas, okay, can I find it out, this addition of all the areas? Yes, I can find out addition of all the areas. Okay, then what do we know? We know that integration of f of x with respect to x for all the real values of x, that is from minus infinity to infinity, is equal to 1. Correct? Isn't it the same thing as we did for a discrete random variable, where summation of probability of x taking all values of x is equal to 1? Correct? So if that is the case, then for a continuous random variable, we can say the mean or the expectation, okay, is equal to mu, which is nothing but E of x. So this is equal to integral of x into f of x dx for all real values of x, that is from minus infinity to infinity. What is this f of x? F of x is the probability density function for this continuous random variable x. Isn't this looking like for a discrete random variable mu was equal to what? It was equal to summation of x into probability of x taking this small value x, correct? So here, instead of the summation, we have replaced it with integration, okay, for all real values of x. Similarly, variance, which we represent it as sigma square, or in short form we write it as variance of x, like this. This is equal to what? This is equal to, again, E of x square, that is mean of x square minus mean cos square, okay? So we say this is mean of square minus square of mean. This is just a way of remembering the formula. This is how we say mean of square minus square of mean. So in short, this will be equal to what? This will be equal to integral of x square into f of x dx, f of x with respect to x when x is varying from minus infinity to infinity, minus, inside the square bracket I'll have integral of x into f of x with respect to x when x is varying from minus infinity to infinity, inside this square bracket, correct? So this is how we find out the variance for a continuous random variable and mean for a continuous random variable. Okay, one more thing. If a continuous random variable x has a probability density function curve such that the probability density function curve, that is y is equal to f of x, has a line of symmetry, has a line of symmetry. Let's try to understand this with the help of a curve. Okay, suppose this is the probability density function curve of some random variable x. This is f of x here with, and this is x here. So this is the probability density curve defined for some particular interval 0 to 4. Okay, to the left the values are 0, f of x has values 0, and to the right of 4 the f of x has values 0. So this particular curve has got a line of symmetry. Okay, it has got a line of symmetry here. Okay, so if it has got a line of symmetry for the defined interval 0 to 4, then this point here is the mean of the continuous random variable x. What will be the mean here? This mean will be equal to mean of this defined interval, that is 0 plus 0 and between 0 and 4. So mean will be equal to half of 0 plus 4, that is equal to half of 2, half of 4 in fact, that is equal to 2. Okay, so that means if a continuous random variable x has got a probability density function f of x defined for the interval, say any interval x lying between a and b, okay, and the graph of y is equal to f of x has a line of symmetry, graph of y is equal to f of x has a line of symmetry for this particular interval, okay, has a line of symmetry in the interval in the interval this one. Okay, in this particular defined interval, then mean is equal to the midpoint of the interval. It is the midpoint of the interval. Okay, so I can directly say here the mean will be equal to half of a plus b. This value here will be the mean. Okay, we will understand this particular concept much better when we will take an example in the next video. That's it for this video. Thanks a lot for staying together this long with this video. If the video was useful and you enjoyed watching it, then please like and share the video. Subscribe to the channel and press the notification bell to receive updates about new videos from this channel. And finally, till we meet in the next video, stay healthy, stay blissful. Radhe Radhe.